All right, so I'm gonna go over this Classkick review for you guys in preparation for your upcoming test, right? Last review that I'm gonna upload a video for. You have a video for the other review and you have videos for all of my lessons, all right? So let's just go over these. So something like x minus 1 to the 2/3, I can change this to radical form, right? So I would put that 3 up front and then make this into a cube root of x minus 1 squared, right? You could also do, I know some other people have maybe shown you guys the reciprocal. I could raise both sides to the 3 halves. But when you do that, it's not as obvious that you're going to get like a plus minus answer, right? But here, when I see this 2, I can square root both sides. And then now when you see that square root, you can think, okay, there is a plus minus there. And then this square root and the square are going to cancel out. I get the cube root of x minus 1 equals plus minus 7. All right. And then I can go ahead and cube both sides of this equation, and then the cube root and the cube cancel, and then I get an x minus 1 equals plus minus 7 to the 3rd power. All right. So to make this easier on yourself, you can separate it. All right. And you can say that this is x minus 1 equals 7 to the 3rd power, and this is x minus 1 equals negative 7 to the 3rd power. All right, so then I get x minus 1 equals 7 to the 3rd power is 343. Add 1. And then we get x is 344. And then I can do the same thing with the other side. X minus 1 equals negative 7 to the 3rd power is negative 343. All right, and then I can add 1 again, and then I get x equals negative 342. All right, and because we had an odd root, this was a cube root, I'm not going to have to worry about any negatives in my final answer or things not matching up, right? Because this was a cube root, if I cube root a negative, you do get a valid statement, all right? So we don't have to check these are fine. All right, now for something that looks like this, some people I saw in class were tempted to do what we were doing before with the reciprocal or raise both sides to the 3rd power, all right? When you do that, that's going to get you a really messy equation, all right? What you should do instead is recognize, okay, well, I have an x minus 1 here and an x minus 1 here. They're the exact same thing, and their exponents, this 2/3 and this 1/3, right? This 2/3 is double the exponent of 1/3. So we can make a u substitution. So I'm going to say u equals x minus 1 to the 1/3. All right, and then when I square both sides, I end up with a u squared equals x minus 1 to the 2/3. All right, so then that's why I would use u as this as the substitution, right? So then we would end up with a u squared minus 5u equals 6. And then I can subtract 6 on both sides, and then I get a u squared minus 5u minus 6 equals 0. And then this looks way easier to factor than what we had originally, right? So this is going to get us a u minus 6, and then a u plus 1 equals 0. And so I get a u equals 6, and then a u equals negative 1. And then I can go ahead and back substitute, right? I can replace this u with what it was originally. So this is going to be an x minus 1 to the 1/3 equals 6, and then I get an x minus 1 to the 1/3 equals negative 1. All right, and then so to get rid of that 1/3, I can cube both sides, and then so we end up with an x minus 1 equals 216. And then I can do the same thing over here, cube both sides, and then I get an x minus 1 equals negative 1. Right, adding 1 to both sides over here, I get x is 217. Adding 1 to both sides over here, I get x equals 0. All right, and then once again, we had a cube root in this original equation, so we don't really need to check that these solutions work, right, because the negatives aren't really going to give us any issues. All right, something like this should be super, super easy, right? I see both sides have a root with the same index. All I have to do to get rid of these is to cube both sides, right? So then the cube root and the cube are going to cancel out. And then so we end up with a 2x minus 7 equals 7x plus 9, all right? And then we're left with a super easy linear equation. I just have to subtract 7x on both sides, and add 7. And so I end up with a negative 5x equals 16. And then just divide both sides by negative 5. And so I get x equals negative 16 over 5. All right. And then once again, a cube root, odd roots, we don't have to check. I know that this is going to get us a true statement because we are allowed to cube root negatives. All right. Something like this might take a little bit more work, right? So if I have 2 square roots in a single problem and then a number with it, right, we're going to have to get one of our square roots by itself first and then square both sides, simplify as much as we can, and then get the other square root by itself. Right? So what I'm going to do is I'm going to subtract the square root of x on both sides and then get this radical by itself. All right? You could have done the same thing the other way around, right? You could have gotten the square root of x by itself, all right? But I'm going to do it this way just because it'll make the math a little bit simpler. All right? But either way, you should get the exact same answer. So I get square root of x minus 24 equals 2 minus the square root of x. And then I can go ahead and square both sides. And then the square root and the square are going to cancel out. So I can x minus 24 equals, this is the same as 2 minus the square root of x times 2 minus the square root of x. So then I get an x minus 24. I can FOIL this. And this is going to get me, when you simplify this, 4 minus 4 square root of x plus x. All right, I kind of skipped a little bit of steps there, but I feel like I don't need to show you guys the foiling, right? You guys can do the foiling yourselves and verify that this is what you get, all right? Because I've done it a couple times in some other lessons as well. All right, so what I can do from here is subtract 4 on both sides, subtract x on both sides. Now, lucky for us, the x cancels out. Now, it's not always going to cancel out, right? Sometimes you will be left with a binomial on the other side that you'll then have to square, and then it'll get a little bit complicated, right? But this is a nice case where we get the x does cancel out. So I get negative 28 equals negative 4 square root of x. And then so what we can do is I can divide both sides by negative 4. And then so I get 7 equals the square root of x. And then lastly, I can square both sides and I get 49 is x. All right, so we get this as our answer. We do need to check, though, that this does work. So I'm going to check over here. And if I do x equals 49 into the original equation, I get the square root of 49 plus the square root of 49 minus 24 equals 2. And so I get 7 plus 49 minus 24 is 25. And the square root of 25 is 5, so I get 7 plus 5 is 2, which is not a true statement. So this actually doesn't work, and our answer is actually a no solution. It's not always going to be a no solution, so it's something that you should check. Because, for example, let's say this wasn't a plus, this was a minus. All right, this actually would have a solution. It would have the same answer. It would have 49 as your answer, but it would work. Right, so that's just one thing to keep in mind, that sometimes it does work. All right. And then, like I've said a couple times already, right, if you feel like you're running low on time, you should save the check for the end, right? Honestly, once you get the answer, you feel free to move on, just because you'll lose probably 1 point from not checking an answer, and it is a no solution. All right, so now we get to our inequalities. Writing our answers in interval notation, we do based on whatever we get as a graph, right? So first I would solve this inequality as if it was an equal sign. So I'm going to do a minus 4 on both sides, and then I get a 2x squared minus x minus 4 equals 0. And then this doesn't factor, but we can do the quadratic formula. So this is going to be x equals 1 plus minus the square root of negative 1 squared minus 4ac, so minus 4 times 2 times negative 4, over 2a, so over 2 times 2. All right, so this is going to get me 1 plus minus the square root of 1 plus 32 over 4 equals 1 plus minus the square root of 33 over 4. All right, so we get two answers here, and if we plot them on a number line, the smaller one is going to be the one with the minus, so it's going to be 1 minus the square root of 33 over 4. And the bigger one is going to be the one with the plus, right? So 1 plus the square root of 33 over 4. So now the challenge here is trying to figure out, well, we want to test 0 whenever we can, but where is 0 going to go? All right, I'll tell you now, it's going to go in the middle, right? But let's see why it's going to go in the middle. All right, so take this number here, 1 minus the square root of 33. All right, I don't know exactly what the square root of 33 is, but I know for sure that it's bigger than 1. So 1 minus the square root of 33 is going to get me a negative number, and a negative number divided by 4 is going to get me a negative number. All right, so if I do 1 plus the square root of 33, well, 1 plus a positive number is going to be another positive number. And then divided by 4, which is also positive, this is also going to be positive. All right? So then I get a negative and a positive, right? And then 0 is always going to go between a negative and a positive. All right? So 0 is going to go in this middle section right here. All right? So you kind of need some number sense, right? Think through the numbers a little bit and see what makes sense. All right? Now, testing 0 into our original inequality, I get 2 times 0 squared minus 0 is less than or equal to 4, which is 0 less than or equal to 4. That does work. So then this middle section works, but these outer ones do not. So I'm going to shade in between, and then I would have closed circles because it's with equality. I see that line underneath. Right, now writing our answer in interval notation, it's going to be bracket 1 minus the square root of 33 over 4, comma 1 plus the square root of 33 over 4. And then that's our final answer, right? This is the answer that you would circle or you would write on that line, right? The one in interval notation. All right, so there's a couple more. This absolute value one should be pretty easy, right? So I have the absolute value of x minus 5. I have a 2 on the outside and a 4 on the other side. So I want to get that absolute value by itself. Let's divide by 2. I get the absolute value of x minus 5 is less than or equal to 2. All right. So what we can do is we can split this up into 2 equations. I would have x minus 5 equals the original, and then I would have x minus 5 equals the opposite of the original. All right, so then I'm going to go ahead and add 5 on both sides. I get x is 7. Add 5 on both sides over here, and I get x equals 3. So I would draw these on a number line, 3 and 7. And then you can pick a number again, right? 0 is the easiest one. 0 is going to go all the way to the left, all right? And that's going to be in this little interval. Let's just see if this works, all right? 2 times the absolute value of 0 minus 5, less than or equal to 4. This gets us 2 times the absolute value of 5, which is 2 times 5, which is 10. Less than or equal to 4, that does not work, all right? So this section doesn't work. The middle one does. The outer one does not. Right? And then because this had a line underneath, I'm going to do closed circles and then shade in between. So then my answer in interval notation is going to be bracket 3, comma 7 with another bracket. And then that's your final answer. All right, I'll try one more on here. All right, so rational equations, inequalities, I want to get the 0 on one side and then our fraction on the other. So this is going to get me a 5 over x minus 2 minus 2 over x plus 3 is less than or equal to 0. Now to get a common denominator here, they don't have anything in common. So what I would do is I would do an x minus 2 and the x plus 3. So then I can go one by one. I'm going to look at this one. It has the x minus 2. It's missing the x plus 3. So this is going to be a 5 times x plus 3. And then the other one, this one has the x plus 3, but it's missing the x minus 2. So I'm going to do a minus 2 times x minus 2. All right, is less than or equal to 0. All right, and then I can distribute that 5, distribute that negative 2, and I get a 5x plus 15 minus 2x plus 4 over x minus 2x plus 3 is less than or equal to 0. All right, and then to clean up the top, we would do 3x plus 19 over x minus 2x plus 3 is less than or equal to 0. And then from here, I can set the top and the bottom equal to 0. All right, so the top would be, I can do that up here. It's going to be 3x plus 19 equals 0. The bottom is going to get me an x minus 2 equals 0 and an x plus 3 equals 0. All right. And then what we get for x is negative 3 over 19, 2, and negative 3. And then I would plot those points on the number line. Right, our 1 all the way to the left is going to be -3/19, and then a -3, and then a 2. All right, the easiest number to test is 0, and 0 is going to go between -3 and 2. When you plug that number into the original inequality, I get 5/0 minus 2 is less than or equal to 2/0 plus 3, which is going to get me -5/2 is less than or equal to 2/3. That does work. So I would have to shade in that region. The ones right beside it don't work, and then the outer one doesn't, right? So these always alternate, all right? And then the circles that we would get, originally, looking at the original problem, we would have closed circles because of that line underneath. But because we have numbers on the bottom that when we plug in we get 0, we need open circles, right? So this is the only case where you need to be mindful of, you can't just look at the original problem and then fill in the circles, right? You need to check that you don't get 0 on the bottom. So then writing this answer in interval notation is going to be -infinity to -3/19 with a bracket, right? Because this one has the closed circle. Union, and then the -3 to 2 is going to have the parentheses because of what we just mentioned, right? It's going to be with the open circles. So then this would be your final answer, right, in interval notation, right? I won't look at your graph. I won't look at the inequality statement that you might get. I'll only look at your answer in interval notation, but draw the graph to help you write it. All right, and that's your last review.